Hi, folks. Welcome to week 6. Well, here's the good news. And the good news is you have so much knowledge that you have acquired so far. You know how to set up physics problems. You know how to draw force vectors. You know how to do basic trigonometry. You know how to do multi unknown algebra problems, two equations, two unknowns. You know the basics of how to do physics. So for the rest of this course, it really doesn't get any harder, at least on our level of physics. What we're going to do from here on out is we're just going to tackle new topics and some new equations. So from here till the end of the semester, it's going to be a new topic, new ideas, new equations, but the mechanics doesn't change and does not get any more difficult, which I always think it's kind of nice to get to that point. You've got the basic skills, now let's use those to get more knowledge. Let's take a look at what we're up to this week. First off, let's take a look at our schedule. Our schedule, remember the dates are going to be different, but we're at week 7, actually, week 7, we're into rotational motion and gravity. So as we do this module 6 on rotational motion and gravity, it's all about rotation. This week you're going to do a whirly lab, you're going to do a chapter 6 study guide and a chapter 6 homework. Next week you're going to do chapter 7, a lab and a study guide homework, and then have a test over both chapter 6 and 7 out of that textbook. And that's pretty much the way it's going to be for the remaining weeks. It's going to be about a chapter a week. And that's because you've got the basics. Now we're going to add more knowledge. A couple of those weeks are going, or topics are going to be 2 weeks when we get to heat, when we get to sound. But most of the time between now and then, it's going to be like a topic per week. So let's take some specific time and look at we're up to this week. Rotational motion and gravity. We're going to start with centripetal force. Centripetal force is the force that's directed towards the center of a circle. And we're going to be talking about that. That is the generic name for any force towards the center of a circle, is that centripetal force. Of course, you're going to have a study guide. There is going to be some equations for centripetal force and centripetal acceleration, of course, with some example problems. As always, there's going to be a problem set. And then we're going to talk about Newton's universal law of gravity. Big important rule. This is still the law of gravity that holds the Earth next to the sun and the moon next to the Earth. So it is a big deal. We're going to talk about G-forces. G-forces are interesting because they're not really forces. They are rates of acceleration, and lots of fun illustrative videos here, some of my favorites. And so I got a little carried away. Please watch these. Many of them are short, 1 or 2 minutes each. Some test pilots going through some G-force training, cats in a zero-G environment. The musical group OK Go, that they actually filmed this video in zero-G. This gentleman breathes through 9 Gs, kind of wacky to watch what he has to go through. And then Colonel John Strapp taking over 40 Gs. So those are pretty extreme videos. Let's talk about our lab for this week, Whirly. And the reason it's called Whirly is in this lab, you are literally going to be whirling things above your head. I've included lots of pictures because you need those to illustrate what you're going to do. In your lab kit, you have a small bobber. You're going to tie this on at the end of a string, then take that string, measure out a 30-centimeter radius. I think that's what it's asked for in the lab. Take that string, put it through a piece of plastic tubing, and then keep going downward. Put that string down and then tie it to a baggie. Now you are going to keep adding washers into this baggie down below because you want to keep changing the weight hanging down in that baggie. So you're going to continuously change the weight. What you're going to keep constant is you're going to keep the radius constant, and then the length here doesn't matter. And you're going to constantly change this every trial, you're going to change that weight. I'm going to ask you to make some dark marks on the string above and below that piece of plastic tubing because of the fact that those marks will help you keep that radius steady. The idea is as you twirl this around in a horizontal circle above your head, so you're going to twirl it around like this, your hand is only going to touch that little piece of plastic tubing. Nowhere does your hand touch the string. So it's just the rotation that is going to, rotational speed, that's going to keep this whole apparatus at the right altitude. You spin too slow, the bobber is going to come in and the whole apparatus is going to fall. You spin too fast, the weights are going to rise and the radius is going to expand. So you're going to have to adjust your rate of spin, slow it down, speed it up in order to keep the radius steady. And if you don't do that, you're going to have bad data and you're going to get bad results. So that's really, really tricky. Now you're going to time how long it takes for 10 complete rotations above your head. When you do this, you're going to time for 10, divide by 10 to get the time for one rotation. Read this section really carefully where I give you some hints about how to get exactly 10 rotations. When you start counting, count by saying 0 and then count to 10. So then when you divide by 10, you have 10, not 9. So read that really carefully when you get to that section. So you're going to have the mass of the washers. You're going to keep adding those washers. You're going to keep the radius constant. Eventually, you want the time for one rotation. You're going to use this information, the time and the radius, time and radius, these two columns. Use that plus an equation to calculate centripetal acceleration. Then you're going to make a graph of force and centripetal acceleration, and you are going to use that, and out is going to pop a mass. Now, force, centripetal acceleration, the slope of that graph is going to be mass. And I'll give you a big, big hint. It is going to be the mass of the object that was moving in a circle. You'll figure it out. That is your true value. The slope of that graph, that's your experimental value. And this lab will give you excellent results if you are careful of it. And I know you can do a good job. Follow all of the instructions of how to make a good graph. Make sure you insert a copy, label everything appropriately, and answer the questions, and you'll be in good shape. Because it's been a while since we've graphed on Excel, there is a reminder of our video on how to graph on Excel, and that is what we are up to this week. So have a good one. Have fun with rotational motion. It's a fun topic, and I hope you have a ball with it. So we'll talk to you soon. Bye-bye.